Hi, welcome to Algebra 2 Common Core. In tonight's lesson, we're going to take a look at transformations of trigonometric functions. We're going to apply the same transformations that we saw in previous lessons on other types of functions now to our trigonometric functions. Trigonometric functions are also sometimes called sinusoidal functions. So we'll be looking at vertical dilations, we'll be looking at vertical shifts, and we'll be looking at horizontal shifts. So let's look at example number 1. We're starting with the function y equals sine of x. And we're going to consider the function f of x equals the sine of x plus 3. We want to know what would happen to the graph of y equals sine of x to produce the graph of f of x. And yes, we know that this is going to be a vertical shift. So we should remember that we can shift graphs in the vertical direction by adding or subtracting a number to the whole function. So this one is going to be a shift up 3. So let's go ahead and take each of the points and plot a point that's 3 above each one, and then go ahead and connect these points in a nice smooth curve. So I'm starting with my sine function. Oops, made a little mistake there. And I'm getting exactly the same shape, so it's our sine curve that has been shifted up 3 units. So of course the blue graph is the graph of f of x equals sine of x plus 3. Now we can take a look at this, and even though the question doesn't ask it, let's denote the range for this graph. We see that the range actually goes from positive 2 to positive 4. And I'm going to put that in interval notation. Now let's look at example number 2. For example number 2, it says consider the function h of x equals 2 cosine of x plus 1. So we want to go step by step through obtaining the graph for h of x. Let's begin in part A by graphing our basic parent function f of x equals cosine of x. So take a moment and plot the function cosine of x. You should recall that the cosine at 0 has an output of 1. Then it goes to 0, then negative 1, then 0, and then 1. So try to remember what the pattern is for the cosine function as well as the sine function. So I repeat the pattern going to the left of the y-axis. And then I'm going to connect this with a nice smooth curve. Now again, in today's lesson, you're going to want to have some different colored pens available so that you can show all of the graphs on one set of axes. In part B, we want to go ahead and graph the function g of x is equal to 2 cosine of x. Now for this one, we know that we are going to multiply each of our y values by the constant 2. So of course this should be a vertical stretch. So every place I have a height of 1, I'm going to get a height of 2. Every place we have a height of 0, 0 times 2 is still 0. Negative 1 becomes negative 2. 0, 2, back to 0, negative 2, 0, and 2. So connecting these points, this graph is the kind that we looked at in our last lesson where we were doing the vertical stretching. So it should look something like this. Now we should label that graph. That one is our g of x graph. And again, also I've shown it in a different color. Now our last step is to take that blue graph and now apply the transformation h of x. So h of x says take the function 2 cosine of x and add 1. So if I'm adding 1, that means that I am doing a vertical shift And my vertical shift is going to be up 1 unit. So I'm going to take all the points on the blue graph and move them all up 1 unit. So vertically doing a transformation. And again, I'm basing it on where the blue graph is. So go ahead and connect those points. So you'll see that the shape of the graph should stay the same. Whether we've stretched it or we've shifted it, we're still getting that up and down peaking exactly the same as our original cosine graph. Now, what's going to be the range for this red function? We should see that the low values are at -1 and the high values go up to 3. So our range goes from -1 to 3. Now in example number 3, we're going to consider the function h of x is equal to -4 sine of x plus 2. So for this one, my parent function actually is sine of x, but I'm going to jump to the second step and say let's do the function f of x equals 4 sine of x. I think we're to the point where we can graph 4 sine of x without having the graph of sine of x in front of us. So we know that the sine graph goes through the origin. At 0, it has a function value of 0. Our regular sine graph would go up to 1, but because I've got a 4 in front of it, it's going to be multiplied by 4, and I know that this is actually a stretch of 4. Then it's going to go back down to 0. Normally I would go to -1, but I'm multiplying by 4, so I'm going to go to -4, and then back to 0 again. Going in the negative direction, I should be at -4, back to 0, up to 4, back down to 0. So I should know the general pattern of what's happening at each of the quadrantal angles for both my sine and cosine graph. So the black graph is going to be the graph of f of x. Now think about what's happening for part B. If I want to graph the function g of x equals -4 sine of x, I should see that the only change that I have made is to negate each of the values. Do you remember that this is actually a reflection over the x-axis? So if I take all of my points and reflect over the x-axis, those that are on the x-axis will stay on the x-axis, and all the rest will flip to the opposite side of the x-axis. So again, I'm getting the same shape, but this time my peaks and valleys are going to alternate positions. So I have the blue graph now, which is going to be my graph of g of x. Now let's take our very last step here, and for the last step we see that we want to add 2. Well, adding 2 just means that I'm going to take the blue graph and I am going to do a vertical shift of the blue graph up 2 units. Now you'll notice that I didn't give us a big enough sheet of graph paper, so I'm just going to have to go slightly off of the graph paper, but again remember I'm beginning with the blue graph. So I want to take each point and shift it up 2 units. So up 2, and when I get where it's too tall, I'll just go off of my graph paper. Now go ahead and connect those points. And I've got the red graph, which is basically just the blue one that has been shifted up 2 units. For the range of this red graph, so again, this is the range for h of x, we're going to say that the lowest y value is equal to -2, and the highest y value is going to be equal to, I guess that would be 6 once I shifted everything up 2 units. So my range should be from -2 to 6. So we can see that our vertical shift is going to be quite easy. All we're moving is up or down from our basic graph. Now, just one other thing that I'd like to point out on my graph. Did you notice that our original graph had as its middle the x-axis? So the hills and the valleys all came off of that middle line, which was the x-axis. Now we can find the middle line for our red graph as well. So I'm going to graph the middle line in purple here. The middle line should be right down the middle of this red graph. I'm going to put it as a dotted line right here. So this purple midline is what we're talking about in the box underneath our graph. It says for curves that have the general form y equals a sine of x plus c and y equals a cosine of x plus c, the value c is called the midline, or the average value. So for this one, we see that our c is equal to 2. So what that tells me is that's the midline of this graph, or it's the average value. It's the value that's actually right between my high and my low values on the range. For example number 4, what I'd like you to do is pause the video and do part A, where you're going to graph the function f of x is equal to cosine of x. And then come back and we'll talk about the graphs of B and C. So you can see on my graph, I've got the graph of f of x, which is cosine of x. Now for part B, it says let's graph g of x is equal to 2 cosine of x. So we should know that g of x is of course going to be a vertical stretch. We're going to multiply each of our coordinates by 2. So pause the video and do that vertical stretch of 2 on your graph. Now check your graph carefully. Make sure that the x-intercepts for the black graph and the blue graph match. And make sure that your heights go all the way up to 2 and the valley parts go all the way down to -2. Now for our last transformation, we're going to look at this equation for h of x. H of x says let's graph 2 cosine of x minus pi over 2. Do you recognize that as a horizontal translation or a horizontal shift? Now you'll remember that when we did horizontal shifts, we always had to look at the opposite of the sign with the x. So in the case of x minus pi over 2, what that really means is that we are going pi over 2 to the right. So for each one of my points, I'm going to move it pi over 2 to the right. Now if you carefully look at your x-axis, you'll notice that the intervals are all in terms of pi over 2. So we just want to move each point 1 box to the right. So I'm going to go 1 box to the right, 1 box to the right, and again I'm going from my blue graph originally. So each of them are going to move over to the right 1 box. Now you'll see that I'm going to also have to go back and fill in what the pattern would have to be back here at -2 pi. So at -2 pi I should have an answer of 0. So go ahead and graph this. Now, when we moved it to pi over 2 to the right, the graph that we came up with should be a familiar graph for us. See if you can write down what the equation of that red graph would be in another way, other than how I've given you the horizontal shift. Can you think about what that equation actually would be? Now, let's go ahead and do a conclusion here and write down all that we found out from this lesson. First of all, number 1 in our conclusion, if we've got a graph of y equals a sine of x, and then we're adding or subtracting c, the c value is going to be the shift, and that's going to be in the vertical direction, so it's going to be up or down. So the vertical shift is going to be the direction that the sign tells us. If I've got a plus, that means shift up. If I've got a minus, it means shift down. If I've got the equation y equals a sine of x minus b, since the b is in the parentheses with the x, I know that the b is going to be a horizontal shift. But because I'm subtracting b, I'm going to say b is going to be a shift to the right. In order to get a shift left, our equation would have to look like this. Y equals a sine of x plus b. And in that case, we're going to have a shift of b to the left. So in this lesson, we talked about both vertical shifts and horizontal shifts. We talked about our midline value, and we also talked about what the range of the new functions that we graphed were. So thanks very much for working on our graphs again tonight. We'll be continuing with graphs in our next lesson as well. Have a great night, and we'll see you next time. Bye-bye.